Today we are learning one of the most important practices used by real software teams, CI/CD with GitHub Actions. Until now, whenever we changed our project, we manually ran commands such as npm install, npm run build. But what happens when several developers work on the same application? One developer may forget to run the build, another developer may push code that works on their computer but fails in production. Someone may introduce a TypeScript error without noticing it. To catch these problems early, teams use automated workflows. Today we will create a workflow that automatically installs our project dependencies and builds our Next.js application whenever code is pushed to GitHub. We will first push working code and see a successful build. Then we will intentionally introduce an error and see the workflow fail. Finally, we will correct the error and confirm that the build becomes successful again. So what is CI? So let me switch to cursor and let's open the sketchpad. So what is CI? CI means continuous integration. Continuous integration means developers regularly push their changes to a shared repository and automated checks verify that those changes have not broken the project. For example, after every push, the system may automatically install dependencies, run formatting checks, run linting, run tests, build the application, check for security problems. In today's simple workflow, we will perform two main operations: install dependencies, build the application. So CI means continuous integration. Now what is CD? CD commonly means either continuous delivery or continuous deployment. Continuous delivery means the application remains ready to be deployed after automated checks pass. Continuous deployment goes one step further. Successful changes may automatically be deployed to production. Today we are mainly focusing on CI. Our workflow will check whether the application can be built successfully. We will not automatically deploy it. What is GitHub Actions? GitHub Actions is a GitHub's automation system. It allows us to tell GitHub whenever a particular event happens, run these commands. An event could be a push, a pull request, a new issue, a release, a manual trigger, a schedule time. For today's workflow, the event will be whenever code is pushed to the repository. A workflow using the push event can run whenever a change is pushed or a pull request is merged. So for today's workflow, the event will be whenever a code is pushed to the repository. So a workflow using the push event can run whenever a change is pushed or a pull request is merged. Now let's create the workflow folder. Open the Next.js project in Cursor or VS Code. In the root directory, create a folder named .github. So let's create inside this. Inside it, create another folder named workflows. And inside the workflows folder, create a file named build.yaml. The complete path should be .github/workflows/build.yaml. So this is how the structure looks like. GitHub automatically looks inside .github/workflows for workflow file. Now let's add the GitHub Actions workflow. Open build.yml and add this code. This workflow uses the current documented major version of GitHub's official checkout and node setup actions. So this line indicates the name of the workflow. This is the name displayed inside the Actions tab on GitHub. You can choose another descriptive name such as name continuous integration or name install and build. Then trigger. This tells GitHub to run the workflow on every push to every branch. For example, it will run after pushing to feature/navbar, feature/contact form, fix/build error, or any other branch. GitHub Actions also allow to restrict the trigger to a particular branch. But today we want it to run on every push. The push event supports branch filters when more control is required. These are the permissions. The workflow only needs permission to read the repository contents. Giving a workflow only the permission it needs is a good security practice. Don't give more than required. Then a workflow contains one or more jobs. Here we have created one job named build. In a larger project, we might have several jobs like lint, test, build, security check, deploy, or any other name. A runner. So a runner is the machine on which the workflow executes. GitHub temporarily provides an Ubuntu machine for this job. The runner will download the code, install Node.js, install dependencies, build the application. After the workflow finishes, that temporary environment is removed. This is useful because we are testing the project in a fresh environment rather than relying on files already present on our computer. Initially, the runner does not contain our project. The checkout action downloads the repository onto the runner, so later steps can access the source code. Our Next.js application requires Node.js. This step installs Node.js version 22 on the runner. The following line enables npm dependency caching. So I will make it pnpm. And here also pnpm. And here also pnpm build. We will be using pnpm. Caching can make later workflow runs faster because GitHub can reuse downloaded package data. The official setup node action uses dependency log files such as package log.json or pnpm log.json as part of the cache configuration. Then install dependencies using pnpm install. So we use this during local development also. In automated workflow, npm CI is usually preferred when a npm log.json file is available. So npm CI is preferred, but for this we can use npm install. It installs the exact dependency version recorded in the log file and provides a clean, repeatable installation. Make sure the pnpm log.json has been committed to the GitHub. Otherwise, this command will fail. Actually, npm CI will fail. This will not fail. So let me ask if there is any npm CI alternative for this command. So let me open the agent and I want to ask what is the pnpm alternative. for npm CI command. Till then we can move next. So this is for building the application. This runs the build script defined in package.json. For a Next.js project, it will normally execute next build. If the application contains a compilation, TypeScript, import, or build time error, the command returns a failure status. GitHub Actions then marks the step and workflow as failed. So this is the equivalent of npm CI. So let us use this. Now let us commit the workflow. So let us check the status of change file. Git status. Okay, we need to initialize the Git repo. So let's initialize the root as the Git repo. And now let's add all files and commit as init. Git branch as main. And let's add the remote. Git remote add origin real engineering day 29. So it is github.com. Yes, session 919. https://git. Now let us push the code. Now let's open the repository on GitHub. So I think it did not detect the actions. Maybe because we did not keep the folder in the root, but inside another folder. The workflow folder should be inside the root. So let's change it. So let me cut it from here and paste in the root. So I need to update this. I need to install the dependencies in a folder course platform. So let me use AI for this. So modify this workflow as the Next.js app is inside course platform folder. So it is saying I will check the current workflow and how the app is laid out. under course platform, then outline the exact changes. So these are the changes that I need to make. It is in ask mode, so it could not edit the file directly. So these are the changes that it has made. Default.run not working directory is course platform. And some changes in PNPM action setup and in cache dependency paths. So let me copy this. Or maybe I can ask it to implement this. And then I can see the changes. I just need to switch to agent mode. So I'm not sure where this change has been made. The first change. Okay, so here the change has been made. So we can paste this. Okay. Okay, so I can keep all the changes. Keep file. And now let us commit this. And now let us go back to the GitHub Actions and see. Okay, so there is one GitHub action and it hasn't failed. Now let us look at the logs. No PNPM version is specified. So best way is to ask the AI agent who has made this change that I'm getting this error. So this should have been mentioned with version equal to 9. Let's keep it. Let's commit it. And now let's push it. Let us go back to the so let me show you the cursor screen what change we have made. We have added this line in the build.yml and we have pushed the commit. So now let's go back to the GitHub screen and see if we are successfully building the action or not. So this is the commit that has been pushed, showing across that those actions failed. Let us see the logs. So it is saying that it could not find the pnpm log file. Let's go back to cursor. There is a pnpm log file, but it could not detect that. So let us ask it from the AI and ask it to make the changes, relevant changes. Okay, so we have to increase that to 10 because the pnpm workspace only has allow builds. pnpm 10 CIs and pnpm 9, which requires a packages field. Okay, so there was some extra requirement with version 9 that was removed in version 10. So if we make it to version 10, then things should work fine. Let us commit the code. Let's generate the commit message and commit it and push it. Now let us switch to the GitHub screen. And this is being built. Let's go to the details. So dependencies have been installed. It is building the application. And I think it has been built. Okay. And the job has finished. And we get in a successful action has been executed. So you have seen the individual steps: check out repository, set up Node.js, install dependencies, build applications. These are the various steps. With every step, when every step passes, GitHub displays a green check mark. This confirms that the application can be installed and built in a clean environment. Commands return an exit code after execution. An exit code of 0 generally means the command succeeded. A non-zero exit code generally means the command failed. When this command succeeds, that is pnpm build, GitHub Actions marks the step as successful. When it returns a non-zero code because of a build error, GitHub Actions marks the step as failed. Later steps normally do not continue after a required step fails. So what happened in the complete workflow? This is the sequence. So developer pushed code, GitHub detected the push, GitHub created a temporary Ubuntu runner, repository was downloaded, Node.js was installed, dependencies were installed, pnpm build was executed, GitHub reported success or failure. This is continuous integration in practice. Our current workflow runs on every branch. To run it only after pushing to main, use this. However, software teams usually also check pull requests. A more practical version is this is more practical. This means run after code is pushed to main, run after pull request targets main. What kills requirement retain the simpler every push version. Now let's discuss the common mistakes. First is workflow saved in the wrong folder. So we need to write the workflow in .github/workflow/build.yaml. Second mistake could be incorrect YAML indentation. YAML depends on indentation, so we need to provide proper spaces, and instead of tabs, spaces, not tabs. The next mistake can be missing pnpm package log.json, or in our case pnpm log.yaml. The command pnpm install for the command of this command pnpm install frozen log file will require pnpm log.yaml. So if it is missing, then uh, do pnpm install, you will get the pnpm log.yaml, then add that, commit that, and push that to the GitHub repo. Next mistake could be incorrect Node.js version. A project might require newer Node.js version, so check node minus minus version, then use the corresponding supported version in the workflow. So here we mention the node version. Yes, with node version 22. Keeping the local and CI node.js version aligned reduces inconsistent behavior. Then is the missing build script. Next mistake. The workflow assumes that package.json contains the build script. That is, this script is there. Without it, the command npm build fails. Next mistake can be environment variables missing. Some applications requires environment variables during the build. For example, database URL, next public API URL, auth secret. A project may build locally because these exist in .env.local, but fail in GitHub Actions because that local file is not committed. Secrets should not be written directly into the workflow. They should be added to the repository's GitHub Actions secret when required. For this beginner demonstration, use a page that does not require private environment variables. So why teams use this workflow? Without CI, a developer pushes broken code and the developer pulls it. The deployment fails later. The team spends time finding the source. With CI, a developer pushes broken code, the automated build fails immediately, the exact failing command and logs are visible. The developer fixes it before merging. So CI does not guarantee that an application has no bugs. It guarantees that the automated checks you have configured will run consistently. If you only configure a build, CI checks the build. If you configure builds, tests, and linting, CI checks all three. So today we created our first continuous integration workflow. Whenever code is pushed, GitHub checks out the repository. GitHub installs Node.js. GitHub installs the dependencies. GitHub builds the application. GitHub reports whether the build passed or failed. We also intentionally introduce a TypeScript error uh, not TypeScript error, but the error that keeping the workflow file in a different repo, different folder. And we inspected the field build logs and corrected the structure and confirmed that the next workflow passed. That is how automated checks help teams catch problems before broken code reaches production. Now task for today. So create a GitHub Actions workflow for your own Next.js project. The workflow must run on every push. Use an Ubuntu runner. Check out the repository. Set up node.js. Run npm CI. Run npm build or pnpm build or pnpm install and frozen. Basically this command. Pnpm install frozen log file. So let me write that down. After that, push the working project and capture the successful workflow. Introduce a small TypeScript error or compilation error, push it and inspect the field build logs. Fix the error, push again and capture the successful workflow. The final evidence should show one field run, not followed by one successful run. So share the screenshot of this final evidence in the comments or send it in DM. That's it for today. See you in the next